Okay, now we go to the 3D free body diagrams. So again, for the support reactions, as in the 2D that we have seen before, if the support prevents translation, so a force is developed. If the support prevents rotation, then a couple moment is developed. As simple as that. But now the force's direction is defined by the coordinate angles alpha, beta, and gamma. You remember from the previous chapter that when we learned about the force, force in 3D. So basically you have the alpha, beta, and gamma, which is the angle between what? Between the force, line of action of the force in 3D. For alpha, it will be between the line of action of the force with the positive x-axis. Beta will be the angle with the positive y-axis. Gamma will be the angle with the positive z-axis. Okay, so as we have seen before, cable, even in 3D, so there is just one line. You remove the cable here and then you substitute with the one line of force. Alright, smooth surface support, same, just one normal force, F. Roller, same, just one normal force. Okay, so ball and socket, then there is this is like a pin, 2D pin, so it prevents the translations. So what we have to do, we will have is Fx, Fy, and Fz, depending on the coordinate system. Okay, and then the single general bearing. So basically for a single general bearing, it allows, okay, just understand this. For bearings, we have different types of bearings here. You see the square shaft, then single thrust bearing. Just now it was single general bearing, this is single thrust bearing, and then single, okay, this is pin. Okay, so basically for general bearing, actually it will prevents the translation and rotations, alright, but for bearing it will allow a specific type of directions, movement. Okay, so for instance, for single general bearing, so it will allow this translation. Okay, so for single general bearing, it allows translation. Okay, and of course it allows the rotation. Here it is a x, y. Okay, so m y rotation, it allows this. Okay, it rotates along the axis, its own axis. Okay, it's bearing axis, it is shaft axis, sorry. So if it is a single general bearing with square shaft, so what happens is that it will restrain the rotation. You see, now you have my. Previously you didn't have my. You allow the rotation. This is the rotation, theta, y. Okay, but for the single general bearing, same, but with square shaft. So basically, because the shaft is square in shape, so it cannot rotate. You see, there is no rotation at all. Mx, my, and mz are applied, but it can translate along the axis. Okay, this translation is allowed. Alright, okay, how about another type of bearing, which is single thrust bearing? So for single thrust bearing, basically what happened is, so for single thrust bearing, the difference between single thrust bearing here with the previous single general bearing is that for the single thrust bearing here, you restrain the translation. Okay, you allow this, of course, this shaft to rotate, but it cannot translate. It cannot translate in the axial direction. Alright. Okay, next, so we have this is a single smooth pin. So for single smooth pin, basically you have again the translations, all translational directions are constrained. So you have Fx, Fy, and Fz, right? But here, this is something that you have to be careful. Remember that actually for the pin, 2D pin, basically you have Ax and Ay, but you don't have M, you don't have a couple moment. But for single smooth pin in 3D, you have Fx, Fy, and Fz, of course. because it prevents the translations, but you also have these couple moments my and mz. What does it mean by that? So actually this pin, this bar, it is only allowed to move, to rotate in this direction, right? In the other direction, the m direction and the z direction is not allowed. Alright, so that's why there is no mx here. There is only my and mz. Okay. Next, single hinge. So single hinge basically, of course, it prevents the translations. So there is fx, fy, and fz, because the translations in any directions are not allowed. And then you have the here mx and mz. Where is my? There is no my. Why? Because for single hinge, like the door, you see the door, the one at the door, you allow this door to open and close. So this direction is allowed. My is the direction in rotation in y is allowed. So there is no my. There is no my, right? Okay. Next, for this fixed support, for 2D, remember that for 2D fixed support, then basically you have the ax, ay, and ma. Here, for fixed support in 3D, so basically you have 3 more unknowns. So what you have is fx, fy, and fz, okay, because it's 3D, so you have additional force in z. And then you have the mx, my, and mz, because the rotations are not allowed in any directions. Okay,